Hello, everyone.
Hi there.
Hi there.
Come on. Now, just in case you didn't know, I was on that side of the table a year or so ago. So now I'm on this side of the table.
Uh-oh.
That
Who
keeps
did you
happening.
piss off?
So I know to dance around, you know.
You
and-
traitor.
So this is Zerto Tech Field Day, and I know how much you guys love PowerPoints, right?
Yeah.
So we'll try to fit all of them in.
You have 900 slides, right?
And what?
I cut the slides to 8.
800?
I'd like to introduce Chen, Burshan.
Hi.
He is the Director of Product Management. I'm Shannon Snowden. I'm Senior Technical Marketing Architect for
Zerto.
Thank you.
Zerto.
All right. Just making sure you were paying attention to the session. Okay, so any questions?
All right, very good. Thank you very much.
There's the slide deck. That took me a long time to prepare that deck. So, but what I want to leave up here are the notes. Here's what we're gonna go through.
You're not handing out hypervisors?
Would you like a hypervisor? We gave all those out yesterday. You know the visor with hyper.
Oh,
you know.
yeah. The visors.
First thing we're going to do is walk through the architecture, so I'm just sort of whiteboard it here to level set. So, first of all, who's familiar with Zerto and what we do? All right, so we got some that are, some that are typing that I absolutely know you know what Zerto is like. But we're going to run through quickly. I want to drop the architecture, sort of level set with everybody, and then we're going to build from that. We're going to talk about the components of what they do. Then Hen's going to jump into, hopefully, a live demo, depending on connectivity and the nuances of live demos. And then we're going to jump into some advanced features that really start talking a little bit more about how we integrate and work with storage. Since this is a storage-based event, we thought maybe we would talk about storage. So we're going to talk about some of the advanced features, and then finally we'll talk about cloud architecture, because we're one of the few that are integrated well with clouds. And then we're going to leave some time for wrap up on Q&A. We left that in there in case there was extra Qs that needed As. All right. So I have to get to drawing now, but what I wanted to do is just put some reminders up here, because I want to start throwing in ZVM, ZRA, and VPGs. So that's the virtual manager, replication appliance, and the protection groups. So as I talk about them, if you forget what those mean, that's where they'll be. So we'll start with site 1. And the reason why I don't say primary in this instance is Zerto can go anywhere to anywhere. So what are we? We're a hypervisor-based replication. So we've moved the array-based replication up into the hypervisor. So when you do that, you get, for us, freedom to where we can start going bidirectional, hub and spoke, for example. We can pair sites, 1 or 2 sites, to 5 sites just as easily, because we're virtual or up in the hypervisor. So site 1, let me get the architecture built here. We'll have a vCenter. Then we need some host. And you'll have some storage that's presented to the host. In the, sorry, I can't draw storage to storage guys very well, but here it is. So that's storage going to the host. What we'll have at site 2 is the same thing. We got a vCenter, and we've got ESX host. And we don't necessarily have to have any more than 1, but we'll balance it out. We got a couple of ESX hosts. What we add to the architecture in order to get it operational, really, is the manager and the VRAs. And I'll just call that VRA for short. These are virtual replication appliances. They're Linux appliances that you install after you get the ZVM installed. So what you'll see in the demos is, how many's installed vCenter? Okay, it's a Windows service install, essentially, correct? That's what the ZVM is. So think of when you're starting out installing Zerto, you're installing the equivalent of the install complexity of vCenter of click, 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 and it's installed. And we install as a service on a Windows 2008 server. Once that's installed, then we start pairing our sites and spinning up our replication appliances. And remember, they're taking the place of any kind of below the hypervisor replication. So, but they are based on just Linux VMs. So I'm going to build out the rest of the architecture here with ZVM and VRAs. Each host gets a replication appliance, okay? I'll present my storage to my host. All right, and then we have, I'll change color for connectivity. Then you've got the classic WAN link between your sites. All right. Okay, so that's the architecture. When we have more than one site, we require 2 vCenters, and then we install VRAs for each host, and then we start pairing the sites. So once we have went through the site pairing, which is IP address pair site, that's the level of difficulty that is, okay? Then what would be the next thing after we have the architecture in place? What would we like to do next? I've got my sites paired, I've got replication happening. What's the next ingredient?
Go get a drink.
Well, that's during the install.
Coffee.
Okay. Just add VMs, right? I want to protect some VMs. Okay, so, yeah. So we need to add some VMs in here. So let me make them purple, since I have colors. I went and bought these, and I want to use every one of them. Okay. So here's some VMs. They're being represented on the host, but as we all know, that's just where their compute and everything's happening. And they could exist on any of these volumes. So this could be EMC, net. What's another storage vendor that you want me to list? Nobody in a storage conference knows a storage vendor?
We know them.
Come on, come on.
We just don't want you to list all of them.
Let's make it HP then.
HP? Okay. All right.
Vendor P and vendor V.
Yeah.
So,
VP.
have you talked to any storage vendors yet?
Yes.
And you didn't list any of them? All right. So here we are. We've got VMs at our primary site that I want to protect. Notice they're everywhere. You know, they can be on any of these arrays. They can be on any of the hosts. What I would like to do next is just gather those things up and start replicating them to the other site, right? Being at the hypervisor layer, we don't have to do anything at the storage layer. I don't have to do any vMotions to get them on replicated volumes. I don't have to do any of that. Further, I don't have to sort of do a re-architecture, because a lot of times you're gonna do, and I'm gonna start speaking like someone who doesn't know storage very well, but spindle counts and disk speeds and things for certain apps that you've figured all that out. Well, instead of having to re-architect it, wouldn't it be nice just to gather up those VMs wherever they are and start replicating them and not have to re-architect the storage underneath, right? Would we agree that's better, worse? Okay. That's what you do with when you're at the hypervisor level of replication. What we do is we call that a VPG. And what the VPG is doing is we identify a group of servers that we would like to be protected as some atomic unit or some togetherness. They're either by application affinity groupings, tiers, whatever. If this is my CRM application, multi-tenant, or multi-tiered, I'm getting into multi-tenant with cloud, multi-tiered application, it could be the database, the web front end, whatever. I've just gathered it up into a VPG and I'm replicating it. Now, once I've done that, let's talk about RPOs and RTOs. I'm sure everyone's familiar with those terms, correct? Recovery point, recovery time.
Yep, yep.
Okay, so Hen's going to laugh at the way I described this because it's going to be much more simply than what a director of the product would say. But we would love to not have, our goal here is to be as near to 0 as RPOs as possible, right? So the way it's architected is we're not keeping anything here. It's all being replicated immediately as soon as it happens to the recovery site. So that's where you're going to see, when you look down a list of our VPGs and the groupings that he'll show you in the live demo, you're going to see very, very low RPOs in the seconds per VM, okay? So it's asynchronous, yet we are near to 0 as we possibly can get in the real world in our replication from site A to site 1 to site 2. So do we have any questions so far?
Anybody?
We good? Okay.
No,
We're after
they're not
lunch.
really snarky.
What?
Go ahead.
Okay, so that's the architecture, that's the VPGs, that's the RPO and the RTO. Ken, do I need to add anything else in the architecture?
Yeah, maybe a couple of points that I will mention. You've drawn it as obviously not identical sites at the storage layer.
Yep.
Of course,
Good.
right? So we didn't write what's the storage vendor here, but just to make sure that let's say Dell won't get insulted.
Yes. Dell.
Let's give them some space here.
Okay.
Right, so we can go from literally any vendor to any vendor. There's another thing that we should bear in mind here is that in many cases, DR is an expensive thing to have, right? You have this infrastructure out there that if it's not serving production on a normal basis and it's just sitting there for an event, you use it, what, tops 5 days a year in your DR tests, and hopefully you never have a real disaster. It's a very expensive infrastructure to have. So one of the elements in the infrastructure, in the architecture here, is basically the fact that the sites don't have to be identical at the host level as well. We can have multiple hosts going to just a couple of them, or probably not one for redundancy purposes, but two to many other hosts, right? So if you make this consideration of, and you will see it, I will go back to this point in my demo as well. If you think on your DR as basically balancing between cost and performance, and what's my DR policy in a sense? Do I have to keep the same performance that I have in production when I have a DR event? Maybe I don't have to keep it for everything. Maybe I'm willing to get some performance degradation when I have when I recover in my DR site. You don't really have to put the same infrastructure here, not the same amount of hosts. You can go basically any to any on every level here, and that's a key point in our architecture on how to make DR flexible enough, simple to manage, and also extremely efficient. Okay, and we'll get to also to some of the features that we have. Again, I'll show them through the GUI. It will be much simpler to get a grasp on them, but basically I'll show you how much thought we've placed into balance between performance and cost on your DR.
Yep.
So that's maybe one other thing I would add here. Couple of other points. Obviously, it's bidirectional, right?
Mm-hmm.
You mentioned, and it's actually multi-directional because we're talking about multi-site.
But it's not multi-master, right?
It's not. Well, define I would say it's not multi-copies. If that's what you wanna kind of point out. There's no real master here. So every site is basically a source for its own applications that it's hosting. The other site could be production in a load sharing mode for other applications.
Right.
They can go in both directions. Okay, so
Right, but
So,
I
calling
can
it
have
what is-
applications writing to one replicated data source
Mhm.
in one location.
So the data so the data store that you expose here could be source and target at the same time.
I don't mean a VMware data store, but I have an application writes to a set of files, which is a data source.
Mhm.
That is mastered in one location and replicated to a second location. I
Correct.
can't write to it in both locations
Correct.
simultaneously, right?
Correct.
Okay.
And not only that, I will say, just to make sure, we're talking about multi-sites. It's single master and it's single copy. Okay, you can go in many directions. You can have multiple sites that are connected and obviously working in multiple directions. You can have the flexibility of your LANs being exposed all the time, so that when you need to recover, you don't need to kind of go and rescan the storage, right, in order to attach them to the host, which in large environments can be a big pain.
Okay, so
But it will be a single copy.
So now we're going to have to dig deep.
Hang on just a second, because I may have picked up on something that might help, maybe. Okay, this is what we're working with. We see the VMDKs. Okay, we're not down in the storage array.
I
Okay.
understand
Okay.
that it's a host-based process.
Okay, so just want to make sure that was clear.
Okay, so I've got, let's keep it simple. I've got primary and DR site.
Mhm.
Mhm.
In the ESX host in the primary site, I'm going to install your VRA.
Correct.
Where does that filter driver require the data, the change rate data?
So,
So my application's running in a Windows VM.
mhm.
Mhm.
It's going to write to a VMware data store on an array.
Correct.
Somewhere in the path between the application and that array, you've got to see that right. Where is it?
So we basically sit in the hypervisor, and that's part of what we do around here in the host. And that's how we basically pick up the changes on the fly and move them over. Okay?
Okay, so but are you sitting between the guest and the VMFS, or you're sitting between VMFS and the virtual block layer?
So what we do replicate is obviously the virtual blocks, not the storage blocks, right? Otherwise, we wouldn't be able to work at the VMDK level, right? And then that granularity, and we would take the data from the ESX, right, as it's going down through the storage layer, and get it replicated to the remote site.
Okay, I'm going to ask this one more time. Because there are 5 potential places in the storage stack within ESX where you could install that filter driver.
Okay.
That you could install in the guest
Mm-hmm.
as a file system, block system, or SCSI filter driver.
Yeah, so we don't touch the guests.
Okay. You could install in the ESX host as a virtual disk driver. You could install above VMFS. You could install below VMFS. There are a lot of options here.
Right, so we sit above the data stores, okay? Above the data stores, we don't sit below the emulation of the data stores, we sit above them and below the virtual machine architecturally.
Okay. And I specify what data I want replicated on what basis.
VM basis,
So an entire VM,
an entire VM.
which means that I have to replicate swap data.
No,
Good.
good question, no.
And we'll,
We allow you to designate specific volumes as swap volumes, and I'll show it to you in the demo. Again, part of being efficient, we allow you to designate specific volumes as swap volumes and exclude them from being replicated. They will be seeded, but not replicated.
Okay, so now when we talk about swap volumes, we can be talking about VMware swap or or virtual guest operating system swap space.
Guess.
So, all right, so I can specify which virtual disks I want to replicate.
yeah.
Again, let's be accurate. The whole VM will be replicated, right? You cannot exclude the disk from being exposed and recovered. So it will be seeded. It won't be replicated on a constant basis when it's designated as swap volume.
So if you broke apart
Okay.
the volumes, the VM decays, and he'll show you in the demo, when you look at the individual VM, we can go granular to the VM of, let's say we've set up a data drive on a VM decay, it's a separate one, and we've got a SWAT volume that's a separate one. We can identify and choose this. There's going to be a checkbox that says this is SWAT, so sync the initial and don't sync it again. Just make sure you've constructed that VM correctly at the recovery
Okay.
site. Then your data in your OS will continue to be the near CDP that we can get, and this would be there. So when the VM is failed over, it's constructed correctly, comes up right. Okay?
Okay. And it's asynchronous replication with write order integrity?
Yes.
Yes.
Asynchronous, continuous, that
With-
keeps write order fidelity across all the VMs that build and represent this application, the virtual protection group. Okay?
Right. So I take a group of VMs, I define them to be a virtual replication group because they have data that is dependent on each other.
Mm-hmm.
Whether they are business dependent or they present the application that you want to protect and recover.
Okay. So
Can you
I've got,
protect the VM?
Sorry?
Can you protect the VM?
Yes.
so I've got multiple applications on each on multiple VMs,
Yeah.
and I have limited bandwidth.
Mm-hmm.
How do I prioritize traffic?
I'll show it to you in the demo. It will be simple to see. Promise.